This morning in the Atlanta airport, no one's missing a meal on Mac Wilburn's watch. With 11 restaurants to serve passengers, he's got dining for every destination. And it all started when Mac talked with First Horizon Bank about opening a franchise in the airport. Now it's open for business and cleared for takeoff. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac. First Horizon Bank, member FDIC.
Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Here we go again with another episode of the Space Nuts podcast. My name's Andrew Dunkley, and with me as always is Professor Fred Watson. Hello, Fred.
Hello, Andrew Dunkley.
How are you?
How are you doing? Yeah, well, thank you. Still alive, which is
good
great.
to know. That's good to know. And I hear that Kathmandu now has a Twitter page.
He does, yeah. The cat has, in response to popular demand, he has his own Twitter feed. He woke up this morning just long enough to sign in, and then he went off and had his breakfast, then went back to sleep. But within 5 minutes, he had 4 followers.
Oh, I think he's got a lot more than that now, because people on the Space Nuts podcast page have been asking for a photo of Mandy. Yeah. So I did put that up, and with the Twitter link. So I dare say he's going to have many more friends very, very soon.
Well, that'll be very good, because God knows he needs them.
Well, yeah, that's if he ever wakes up to actually read the messages. But, yeah, that's great news. He's a funny old fellow, is Mandu. Now, today, Fred, we've got a couple of things to talk about that are of great interest. When we're talking about life and how it gets around the planet, something could be said for how it gets around the universe as well, perhaps, because they've looked at how microbes travel on Earth, and they get around. They do get around, and we'll explain that very soon. We've also found an Earth-sized rocky exoplanet, which could be life-sustaining, except for one minor glitch from what I read very, very quickly. And we're going to answer some questions. We got a question only yesterday, in fact, from a young fellow who messaged me and said, I'm not sure where to ask questions. Is this okay? And I think it came up as a Facebook message. And I said, yeah, sure, I'll send it to Fred. And, well, you're going to tackle it straight up about fly-in, fly-out astronauts, I think is the basic crux of the question. So we'll look into that. There was also a question following on from something we talked about recently, and that was the Israeli crash on the moon that may have, put life on the moon inadvertently. And someone says, well, okay, they broke international law by doing that, but what about Changi 4 with its frogs and dogs and everything else that they had on board? And we've got a question from a dear old school friend of mine who found me recently. I've been trying to hide from all my school friends, but they've tracked me down. I don't know how they do it. And he wanted to talk about warp drive. So we'll be tackling all of those things on this episode 168 of the Space Nuts podcast. And that's all we have time for this week. No, I know I use that joke a lot, but it's one of my favourites.
Oh dear, it's so close to the bone, though.
Yes, indeed. Now
We've been meaning to tell you, Andrew.
Yeah, I know.
You mean you haven't heard from management yet?
No. Maybe that's because I'm management. I don't know. Now, this first story is all about how life can move around, and they've been looking at microbial life and how it disperses using dust as a transporter. This is rather fascinating and probably could open the door into how life may have moved around the universe even.
That's correct. It's a paper, a scientific paper with a very dry title, which is Aeolian Transport of Viable Microbial Life Across the Atacama Desert, Chile, Implications from Mars. And I think most of its authors are from either Chilean or Spanish institutions. Mm-hmm. But what they have done, I think they're Spanish actually, from Madrid's Centro de Astrobiologia. There you go. It's my best Spanish. It's rubbish, isn't it, really?
Well, it's better than mine.
Anyway.
I'm going to say that's the University of Madrid.
Yeah, the astrobiology centre. That's right, Madrid. It will be the university, that's right. So what they've done is, and it's a really neat experiment to do, they've gone to the Atacama Desert, and I was in the Atacama Desert only about a month and a half ago, but not doing experiments there. I was looking at the scenery. So what they've done is, this is the driest place on Earth pretty well, apart from Antarctica. It is very, very dry. And it's a desert, and it's warm, and it is near the equator, so it's got pretty hefty ultraviolet bombardment from the sun's rays, so there's a fair chunk of radiation there. But what they did was they basically collected bacterial and fungal entities, species, from basically areas where on either side of the hardest bit of the Atacama.
Yeah.
And they were able to draw the conclusion that the species were different enough, that the sort of indigenous species, if I can put it that way, were different enough so that they weren't shared between the two.
Okay.
But they found that there is evidence. I'm not quite sure how they did this. I'd need to read the paper in a bit more detail. But that there is evidence that the living organisms can actually move across the desert. That they've basically taken samples that can demonstrate that these guys came from the other side, but they're now on the far side of the Atacama Desert.
So they may have done species comparisons and said, okay, well, this one couldn't have been born here.
That's
it must
the
have
sort
come
of thing.
from there, and
That's
the only way that could have happened was transport.
So it's transport, that's correct, or as it's called, aeolian transport in their paper.
Mm-hmm.
So what they were trying to do was essentially, just ask the question, can microbial life disperse, on dust? That's the key thing, that these things hitch a ride on dust particles, which is transported by the wind in the desert. And what their main point is that the Atacama Desert is a kind of analog model for the planet Mars, because Mars is dry and it's got winds, much less atmospheric pressure, much lower temperature. And of course, the other issue is that there is a high level of solar radiation and actually cosmic radiation from bombarding the surface of Mars. So you've got to kind of rule that one out and say, well, we don't know about the radiation. But the fact that, as they say in their paper, a number of viable bacteria and fungi are in fact able to traverse the driest and most UV irradiated desert on Earth unscathed, using wind-transported dust, particularly, they note, in the later afternoon hours. That's when you'd think things would get at their worst. But their suggestion is that perhaps microbial life on Mars, and they say extant or past, may have similarly benefited from aeolian transport, i.e. on the wind, to move across the planet and find suitable habitats to thrive and evolve. So it's a really interesting experiment, an interesting finding that they've done that suggests that maybe, microbes could zoom around on the wind on Mars.
I suppose for a microbe, a speck of dust would be like a planet.
Yes, that's right.
And
exactly.
in those circumstances, for a microbe, they'd be living in a micro environment. So the outer atmosphere, or the atmosphere as we know it, wouldn't be the same for them. They'd often be living in micro bubbles of water and things like that, would they not?
There would if there was any water, yes.
If there was any water.
Yeah. But yeah, that's right. So I think your point's well made that they are taking a ride on bits of dust. And so that will be their whole environment in a sense. So the fact that it's being blown around on the wind is not necessarily detrimental to their existence. What might be detrimental is that, they're being zapped by cosmic rays and things while they're being blown around, which will probably be the case on Mars.
Yeah, okay. But it does sort of open the door into how microbes can travel, and whether or not it's happened on other planets like Mars or some other rocky exoplanet, one of which we're going to talk about shortly. Mm-hmm. It's starting to, the evidence is building more and more about the potential for microbial life to exist, probably as more of a norm than anything.
Yeah, quite so.
And I suppose the question then comes up as to whether or not they could survive space travel on asteroids or the like.
Yeah.
That's
that's the big theory of Fred Hoyle and Chandra Wickramasinghe, that microbes zoom around the solar system on bits of dust and find their way to planets like Earth.
And in our case, it was just right.
Yes.
They ate the porridge and life on Earth.
Yeah, that's right. Porridge was not too hot and not too cold.
Exactly. All right. I'd be interested to see more of this research as it comes out and what else they can learn. The Atacama Desert I've never been to, but you have, and it sounds like a fascinating place. But there's a few places in the world where they've sort of looked at, okay, this is what Mars will be like. Let's see if we can live here for 6 months in a self-sustained environment. And it would be tough. You're listening to Space Nuts, Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Okay, Fred, straight on to this exoplanet that has been spotted. We're finding them at a rate of knots these days. Well, we've hit the tens of thousands in terms of numbers, or over 10,000, I think is the number now.
It's actually 4,000.
Oh, 4,000, was it?
Yeah, with another 600 or so candidates still remaining from the Kepler space mission.
Right, because they're getting the data, but it's the analysis that takes the time, and so they don't count until they've done the analysis. I don't know where I got 10,000 from, but we'll get there.
It's all right. Yeah, it won't be long. You're quite right. It won't be long.
This one is LHS 3844b. What's so special about this one?
LHS usually means left-hand side, but it doesn't in this case. It's a catalogue name, but it has been observed by 2 NASA space telescopes to find out more about it. So LHS 3844b is a planet in orbit around a red dwarf star, 48 light years away as the crow flies. So it's been known since 2018, and it was discovered by TESS, which is the Transiting Exoplanet Survey Satellite, a NASA spacecraft. And what TESS lets you do, basically what it does is it looks for the dip in brightness of a star when the planet passes in front of it. And if you know the diameter of the star, and you know, which you do from its physical properties, and then if you know how much the planet has dimmed the star's light, you basically know how big the planet is in terms of its diameter. And this one turns out to be about 1.3 times the diameter of the Earth. So it's what you might call a super Earth. However, the next step was to try and investigate its atmosphere. And for that, you need a different facility than the TESS spacecraft. And so what they used was NASA's Spitzer satellite. And Spitzer is the name of an infrared telescope, actually. It's one that can look at what we call thermal emission, which is the heat radiation or the heat signature of any object. And so Spitzer was looked at to study the way the infrared light from both the planet and the star. This is the tricky bit. You basically get both together because you can't separate one from the other in the field of view of the telescope. You're looking at essentially a single object. The planet is too close to the star to be resolved, as we say. You don't see it as a separate entity. How close is it? Well, it's close enough that 1 year for this planet, LHS 3844b, 1 year is actually 11 of our hours. Ooh. So 11 hours is quite a quick year, quite rapid turnover in birthdays and things like that.
Yes.
Now, what that means...
You'd be a million years old there.
Yeah, you would be, that's right. What it means is that because it's so close, this phenomenon of tidal braking will have slowed down its rotation. So it always keeps the same face towards the sun. So what that means is it's going to have a hot side and a cold side. But they might not be that different if the planet has an atmosphere. So what you're looking for is some way of being able to find out, whether the hot side of the planet, the side facing its sun, and the cold side are different or similar in temperature. So the way you do that is very, very clever. If you imagine the time when the planet is transiting across the face of the star, so it's going across the star's disk, we don't see that. All we see is a point of light. But the Spitzer telescope can look at that amount. It can basically look at the combination of the star and the dark side of the planet and work out how much heat is being radiated from the dark side of the planet. You follow the logic there, because that's the side that's facing you. You know the amount of radiation that's coming from the star. You plonk the planet in the middle of the star's disk as it goes around in its orbit, and then do the same measurement again. And what you get also includes the contribution of the planet itself, which turns out to be not much more than absolute zero. It's very, very cold on the side away from the star.
Right.
Then you wait till the planet, another 5.5 hours, if it's got an 11-hour year, wait for 5.5 hours until the planet is just about to go behind the star on the other side of its orbit. And what you've got there is an observation of the star with the daylight side of the planet facing you. And so you can make the same measurement. You can work out what the daylight side temperature is. And it is 770 degrees Celsius.
Oh, fun.
So you've got this huge difference, absolute zero on one side, or nearly, not that far above.
The big advantage being if you've got an 11-hour year, you're going to have a really quick suntan to enjoy your birthday.
Yeah, that's right. Exactly. In fact, you might be fried, but never mind.
Yes.
So on that planet, you've got these two very distinct sides, a day side and a night side, with this, almost 1,000-degree temperature difference between them. That suggests that there is no trace of an atmosphere there, because if there was, you would expect, probably very high winds between the hot side and the cold side, but you would expect the temperatures to be evened out, as they are largely on Venus. As Venus plods around the sun, because its atmosphere is so thick, then that tends to even out the temperature between the day side and the night side. On this particular object, LHS 3844b, that's not happening. And so the inference is that it does not have an appreciable atmosphere. So even though it's a nice, roomy planet, just a bit bigger than the Earth, it's got not much to offer in terms of breathability.
So would it be fair to say it's more akin to our Mercury?
Yeah, a big Mercury, that's right.
Yeah, no good.
No.
Yeah, because Mercury's hot on one side, freezing cold on the other.
Yes, that's right.
And people might have trouble getting their heads around that because Mercury is so close to the sun, but you can do the experiment when you're standing in the sun and then step under a tree.
Yes, that's right.
I mean, it's the same effect, isn't it?
It's very similar, yes.
Anyway, so this one, no good for cosmic holidays. But I think they're starting to find candidates that may well be potentially livable planets.
Indeed.
And as we previously discussed with the way back microbial life can travel and fungal life, there may well be life on those planets if they have liquid water. That's the key ingredient.
Who knows? And one
know.
PS to this story, Andrew, I meant to mention that this research has been done by astronomers at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts, one of the great names in astronomical institutions. So certainly the lead author is based there.
Fantastic. All right. Well, there's another non-conformist planet into the life experiment, but we keep looking. We keep on looking. This is Space Nuts. You're listening to Andrew Dunkley, but mostly Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, before we hit some questions, once again, a big shout out of appreciation to our patrons who have signed up at patreon.com/space nuts or pace nuts. Because we're pretty speedy. So 44 people now, Fred, who are contributing to the Space Nuts podcast. So that is fantastic. And we're just so thrilled that you enjoy it enough to put a couple of dollars in the tin. So fantastic. Well done. Thank you. And also I want to mention the Space Nuts podcast group. And I did tell you that I've put a photo of Mandu up there for all to see, and we're getting comments. So that's good too. If you want to join the Space Nuts podcast group, just put a search in for it and just put your request in to join, and that's all there is to it. Just sit back and wait, and after a few weeks of committee meetings and bureaucratic nonsense, we will probably approve it, pending the IOC's approval. But then we might just say yes straight away. And if you do have questions for us, a lot of people say, where do I send questions? The Space Nuts podcast group is designed for you to talk to each other and discuss various astronomical things. So that's what it's for. We do often get questions through our official Facebook page, which is fine. But we find the best way to do it is to send them to our website, bitesz, bitesz.com/spacenuts. Down the bottom of that page is a little contact us or leave a message or comment for us space. Just fill that out and that'll get straight to us, and those questions get fed immediately to Fred and myself. So that's probably the best way, bitesz.com/spacenuts, and that's where you can listen to all our episodes as well. Although we're also on Google Podcasts, Apple Podcasts, Spotify, Stitcher, Podbean, iHeartRadio, Pocket Casts, Castbox, and you can even set up your own RSS podcast feed. So plenty of ways to keep in touch with us. Now, Fred, let's hit this first question. This one only came in yesterday from a young fellow named Devon. Devon Lee. I hope I'm pronouncing that properly, Devon. Hello, Andrew. My question is, would it ever be feasible to send astronauts to work in space daily or possibly bi-daily so the astronauts can return home to help retain calcium in their bones, as well as send smaller, cheaper rockets just as an astronaut shuttle? I believe this would be an interesting experiment that would, at the very least, help us improve smaller reusable rocket technology, as well as minimise the wait time for astronauts to leave the Earth. Thank you for the education and entertainment, and have a great day. You too, Devon. Great question. Fred was really keen to have a go at this one.
Yeah, theoretically, it could happen, but it seems to fly in the face of all we know about space travel at the moment. And it is, that there's the correct, Devon's making the correct comments about things like calcium in the bones, because certainly that's one of the things that bone density is one of the things that gets lost by astronauts. But I think the real answer is that it is not going to be practicable just because of the length of time the human body takes to adapt to space. So you need that duration in zero gravity to be able to work effectively in space. I've been a couple of times actually recently at medical conferences which have been concerned with the effects of spaceflight on the human body. And one in particular, I got a whole lot of information about the effects of weightlessness, and they're very profound. They make a big difference to your body, but you get used to them. And so you can function really well if you take the time in the new environment. So it's a bit like getting over jet lag. Now, I know, and some of my colleagues do this, I've done it for something like 4 days, but I know people have gone to Europe for a weekend from Australia and then come back again. And their comment is that they didn't have time to get the jet lag at the other end, and it kind of cancelled out by the time they get back home. And actually, the couple of times I've made short trips, there's a little bit of evidence of this. But still, I think going into orbit is a quite different thing. You are expending a lot of energy to get up to that 8 kilometers per second that you need to stay in orbit and basically dock with the International Space Station. Then you've got to slow it down to come back to Earth. And I think that's the killer. So,
as well as the expense, I imagine.
Yeah, so just about to talk about that. So at the moment, the canonical price, if I can put it that way, the accepted price for sending things into orbit is about $20,000 per kilogram. It's possible with SpaceX's use of reusable boosters now that might come down even by as much as a factor of 10. And that does put a different slant on the expense, but I still think the economics of it will be much better to send people up there for a reasonably lengthy duration. At the moment, it's 6 months, the standard stay on the International Space.
So it would cost them $1,600,000 to send me into space, based on your...
From which we can work out that you weigh 1.25 tons, is that right?
No. I don't know. Did I add an extra naught?
No, it's me who's being flippant. Sorry.
80
I shouldn't
kilos.
doubt your calculations. I saw you with your pencil and paper there.
Yeah. Well, that's dangerous in itself.
Yeah.
Knowing my mathematical history at school. Oh, dear. So the answer is great idea, but not feasible yet. Maybe feasible in the future.
Maybe so.
But maybe not day trips, maybe shorter stints than they do at the moment. Like they do, several weeks and even months and sometimes longer these days. But yeah, the price you pay on your body is pretty heavy. And that's one of the big challenges, especially if we're going to send people to Mars, which is starting to look less and less likely at this stage. But who knows? There's so many challenges we have to overcome, Devon. So thanks for the question, and hopefully that gave you the answer you may or may not have been looking for. Now, let's move on to our next question. Firstly, thanks for a great podcast, always interesting and good to listen to. Is it ours? Is he talking about ours? Could be. Recently, you were discussing the crash of Beersheba on the moon and the fact that it violated the planetary protection protocol by carrying tardigrades. Yes, we did talk about that. My question is, how is this different to the Chang'e 4 craft sending or carrying seeds and fruit flies, some of which were then germinated in a biosphere? Many thanks, Russell from Wokingham. Is it Wokingham in Great Britain?
It's probably Wokingham. I can't see the question. Somehow I've lost it, but Wokingham, yeah.
It's lucky I keep copies of everything, Fred.
It is, that's right. So the answer is, it's no different. So the planetary protection rules get really stringent when you're going to somewhere like Mars that's got an atmosphere and could have its own viable population of microbes. They are much reduced when you're talking about going to a sterile object like the moon, one with no atmosphere. And in fact, the Mercury and the Sun are other places that you might visit without too much worry on the planetary protection rules. I think to some extent there's a pragmatism about these. Yes, Chang'e 4 took was it fruit flies and I think some seedlings as well, which germinated but didn't last very long. I think they only lasted 24 hours or 48 hours or something like that. So how does that negate? How does that sit with the planetary protection rules? It's probably okay, but I think with Beersheba, the Israeli experiment, I don't know that there was any announcement made that these things were going to the moon before the event, and maybe the protocol would dictate that perhaps you should say, yes, we're going to send a few microbes up there or whatever. And I think they get the tick of approval. I mean, the bottom line is we've sent human beings to the moon and they're just bags of microbes.
Oh,
so
they're just, rancid bags of bacteria and...
Exactly. Well, speak for yourself.
Viral load is high.
That's why you're in Dubbo.
Yes, it's a very safe place at the moment. No water around here.
No, you've not got any water. That's right. Well, so you won't have any microbes at all.
None at all. No.
That's a way. Anyway, I think that's the bottom line. It's a grey area. Let's put it that way, and it will become even greyer when we start sending people to Mars, because the places they'll want to go will be the places where you really require what's called Category 4 sterilisation. I think it's 4C, which is the most stringent, and says that you must have no more than 30 spores per spacecraft.
Oh, God.
Whatever bacteria you're talking about. And then you put a person in there.
Yeah, well, that messes it up, doesn't it?
It does a bit, yeah.
And of course, most of the astronomical world is stunned that Israel would do that without telling anyone. But China, oh my gosh, how could they? I've already been there, so I don't have to go back and get arrested and thrown in a gulag for, dissing China. We'll leave it right there.
We might do, yes.
Thanks, Russell, for your question. Very much appreciated. Let's move on to another one. This is from Tony Buzek. Tony and I went to school together, and as I said earlier on, I don't know how he found me. I've been hiding out here for so long, but some of my schoolmates have started tracking me down. So Tony's a recent joiner of the ranks of the Space Nuts fraternity. So welcome along, Tony. I hope you're looking after my hometown. He says, my burning question regards physicist Miguel Alcubierre. Have I got that right? Thesis on warp drives, like, Star Trek. His theory suggests it would be possible to travel faster than the speed of light by not moving, as your spacecraft would be inside a bubble of space that can travel at speeds that space itself is capable of. The journey to Alpha Centauri could take as little as 2 weeks, as opposed to something like 4.1 light years or 180,000 years at normal rocket speed. I know which I'd prefer. Can Fred discuss this, or is this something you have discussed in previous episodes? Yes, we have. Thanks, Tony, and that's where we'll leave it for this. No. We've talked about it, but it's worth investigating again, because this is a theory. This is a concept that has been brought forward as a potential way of travelling. Whether or not it's feasible versus the theory is another matter.
It's a really interesting idea, which I confess I haven't looked at this work of Miguel Alcubierre's, or whatever his name is, his work on warp drives. But you're quite right that space expands, has expanded, we know, in the past, so in such a way that two places in space are being separated by greater than the speed of light. That's certainly happened. But that's for space as a whole. Now, how you isolate a bubble of space that is going to do something different from that is a very interesting question. And I cannot think of any way in physics or even metaphysics that you'd be able to do that, because space-time itself is the underlying fabric that we are attached to. Chopping out a little bit of it to go its own way is a difficult thing. Then you've got the problem, difficult, by that I mean impossible probably, but then you've got the problem of where do you get the energy from to accelerate it to these extraordinary speeds. And I do remember reading, it's probably about 10 years ago now, maybe even longer, more like 20 probably, some work that was done, I think, in University College London by specialists in relativity, who, and you and I have spoken about this before, Andrew, but they looked at the demand for warping space, literally warping space, so that you bring two places closer together and travel between them at faster than the speed of light. So that's the principle of the warp drive. And the bottom line was that you use up more than the entire energy budget of the universe to do that. So you can do it, but you need more energy than the universe actually possesses. So that makes it a bit tricky. So I think these things will always remain in the realm of science fiction unless there is a breakthrough of a very weird kind. And my guess is that it wouldn't be to do with warping space, that it would be something to do with getting down to quantum mechanics and getting into things like quantum teleportation and things of that sort. But we haven't done that yet. So
I still reckon the time will come when they'll crack this one. It might take a few thousand years, but maybe not. But I do think they will crack it one day. Well,
that's right. Yes, it's a fond hope, but it's so far down the track that you and I are never going to see the first hint of it, I think. No. Unless we get that time machine.
Yes.
Yes. My time machine, I don't know what's wrong with it today, but it was fine tomorrow. Sorry about that, Andrew. I've got to throw that in. It's my only time machine joke.
It's a very good one. I like it. It's worth telling once in a lifetime.
Yeah.
Yeah. But then you can go back in time and hear it again.
Yes, you can.
All right, Tony, thanks for the question. The answer is not yet. Not yet. But maybe one day, many, many moons down the track.
Nice idea.
It is a good idea. And thank you to everyone who contributed this week, and thank you for listening, and thank you for chasing up our podcast group, and to our patrons, to everybody. And thank you, Fred, as always. It's fantastic fun, and we'll do it again next week.
I hope we will. Sounds good. Thanks, Andrew. See you soon.
Professor Fred Watson, an astronomer at large, joins us every week here on Space Nuts, as do I, and we hope you can join us again next week for another episode of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.